If you're stuck on a problem, chances are one of these tips can help. Number 1. Invert. Always invert. Say you want to be happier. Most of us chase happiness head-on and get nowhere. Instead of that, what if we invert the question? What reliably makes me miserable? List those, start cutting them. And happiness has far more room to turn up on its own. That backwards move is centuries old. The mathematician Carl Jacobi was stuck on a family of equations called elliptic integrals, a tangled, intractable mess that defeated everyone who came at it head-on. So Jacobi stopped pushing on the front door and turned the whole question inside out, asking not what the equation gives, but which inputs would give a particular answer. And the inverse was beautiful, where the original was a nightmare, orderly, repeating, like wallpaper. A whole new kind of function fell straight out. Hence the 3-word method he preached for the rest of his life. Man muss immer umkehren. One must always invert. Number 2. Has it been solved before? Here is something working scientists and engineers know and the rest of us forget. Most problems have already been solved. If you care about the result rather than the glory, you go and find where the problem is already solved, and you reuse that solution, instead of trying to reinvent it from scratch. Japan, the early 1990s. The bullet train is about to get faster, and it has an embarrassing habit. It goes into a tunnel quietly, and comes out the far end like a shotgun. At 300 kilometers an hour, it shoves a piston of air down the tunnel. The pressure piles up, and it slams out of the exit as a boom you can hear 400 meters away. Japan's noise limit is 70 decibels, and the train is sailing past it. The engineers throw everything they have at the nose of the train. Nothing they invent is quiet enough. The man who solves it, Eiji Nakatsu, is an engineer and a devoted birdwatcher. He doesn't ask, how do I design a quieter nose? He asks the better question. Has this already been solved? He thinks of the kingfisher, a bird that drops out of thin air into water at speed and barely makes a splash. The trick is the beak, a long, fine wedge that slides from air into water, 800 times denser without a shock. Evolution had cracked this exact problem millions of years before there were trains. So Nakatsu didn't reinvent anything. He copied the bird and gave the train a 15-meter nose shaped like a diving beak. It came in under the noise limit, cut air resistance by about 30%, and used some 10 to 15% less power, while running faster. He borrowed from the owl as well for the noise off the roof, and from the penguin for the body. You can do this with almost anything. Before building something from scratch, spend real time searching whether a similar problem has already been solved in another domain. The answer you need has very often been worked out elsewhere, just under a different name. Number 3. Leverage your subconscious. Some of the best thinking you will ever do happens when you are not thinking at all. The mathematician Henri Poincaré built a method out of exactly that. He spent 15 days trying to prove that a certain kind of function couldn't exist. Every day he sat down for an hour or two, tried combination after combination, and got nowhere. One evening, against his habit, he drank strong black coffee and couldn't sleep. He described it beautifully. Ideas rising in crowds, colliding in the dark, until pairs of them locked together into something stable. By morning, he had the bones of an answer. But the real lesson came a few days later, when he stopped working entirely. He left town on a geology excursion and forgot mathematics completely. And as he put his foot on the step of a bus, mid-conversation, thinking of nothing in particular, the answer arrived. Whole, uninvited. The functions he'd been wrestling with were secretly the same thing as a strange curved geometry. He was so certain that he didn't even check it on the spot. He verified it later in his own words, for conscience sake. The conscious mind had set the problem up, and the back of his mind had quietly finished the job. You already own this machine. You just don't aim it on purpose. Stuck on something? Stop staring at it. Go for a walk, do the washing up, sleep on it, and let the answer turn up in the shower. Number 4. Find fast approximations. The 16th of July 1945 in the New Mexico desert. The first atomic bomb goes off. Every scientist present wants the same number. How much energy did it release? At this moment, that figure is one of the most closely guarded secrets on Earth. Enrico Fermi doesn't wait for the instruments. He has a faster route to the answer, the back-of-the-envelope estimate that physicists live by. As the shock wave rolls toward him, he tears up a sheet of paper and lets the scraps fall from about shoulder height. The blast arrives, and the scraps jump sideways, roughly 2.5 meters. From how far a few bits of paper were nudged, Fermi estimates the yield, about 10 kilotons of TNT. The real figure, found later with careful chemistry, was around 20. He landed inside a factor of 2, pinning down the energy of the blast with nothing more than a handful of torn paper. It is worth pausing on what that number was. It was the energy of a weapon, and 3 weeks after this test, that energy fell on 2 cities. The number itself was deadly serious. The method is yours to borrow. Tempted by a side hustle? Before the business plan, do the napkin version. Rough customers times rough price. Most ideas die honestly right there, in about 30 seconds. Number 5. Learn fast by doing. Hand most people a hard new subject, and they set out to learn everything about it first. They read and prepare. And somehow they never quite begin. The reading feels like progress, and it is the most comfortable way ever invented of putting off the hard part. The faster route is almost rude in its simplicity. Start doing the thing, badly, today, and let the doing teach you what no amount of reading could. Coders even have a name for the trap. Tutorial hell. Course after course, and nothing ever built. The cure is to open the editor today and make a wonky little app. Get Hello World onto the screen, then break it, then fix it. You'll learn more in 1 afternoon of doing than a month of watching. And don't read a textbook line by line praying it sinks in. Turn whatever confuses you into a question and hunt the answer down, in the book, on Google, or from an AI. You are only ever a handful of good questions away from understanding almost anything. Lost in a chapter on interest rates? Don't reread it 5 times. Ask what exactly doesn't click. Answer that, and the next question appears on its own, until the whole thing quietly falls into place. Nobody showed this better than a bookbinder's apprentice named Michael Faraday. He'd left school barely able to read and write. No degree, no mathematics to speak of. He read the books as he stitched them. By the standards of the day, he was not qualified to have an opinion about physics. So he did the thing most people put off forever. He got his hands on the apparatus. He talked his way into the Royal Institution as a bottle washer for the great chemist Humphrey Davy. And from there, he simply started doing experiments. Endlessly. He didn't wait until he understood electricity. He pestered it until it told him something. In 1831, pushing a magnet in and out of a coil of wire, he found it. Move a magnet near a wire, and the wire pushes a current. Hold it still, and nothing happens. The current lives in the motion. That single effect is the principle behind very nearly every power station on the planet. Faraday didn't derive it on paper. He found it with his hands, because his hands were already in the box. He pictured invisible lines of force threading through space. A child's drawing, the mathematician sniffed. It took another man, James Clerk Maxwell, to turn those drawings into some of the most important equations ever written. The professors had the equations. The bookbinder had the idea worth putting into them. Number 6. Chase what doesn't fit. 1964. 2 radio astronomers at Bell Labs, Arno Penzias and Robert Wilson, point a giant horn-shaped antenna at the empty sky, and they pick up a faint hum, a whisper of microwave noise. It's there when they aim at the galaxy, and, irritatingly, still there when they aim at nothing at all. It comes from every direction at once. Here is the part that makes them scientists rather than the rest of us. They refuse to let the noise go. They point it at New York in case it's the city. Nothing changes. They check the wiring. They check the joints. They find a pair of pigeons living inside the horn, and a quantity of droppings they primly record as a white dielectric material. They evict the pigeons. They scrub it out. And the hum stays exactly where it is. 30 miles away at Princeton, a team led by Robert Dick is predicting, on paper, this exact thing. If the universe began hot and dense and has been cooling ever since, there should be a faint afterglow soaking all of space, the cooled-down light of the Big Bang itself. A phone call connects the 2 groups. The noise nobody could get rid of was the prediction. That hum, the hum from the beginning of time, is the oldest light there is, set loose when the universe was young and chilled over 13 billion years to a whisper a few degrees above absolute zero. Penzias and Wilson won the Nobel Prize. They had gone hunting for pigeon droppings and come back with the birth of the universe. If you'd like more videos like this one, do like and subscribe, and the references and further reading for everything in this episode are waiting in the description. Cheers.